All right, so continuing with 9.1, do you remember the period example? A couple of examples ago, we had a set of two-dimensional pyramids where each row we just had one more block. So like the first row had one block, the second row had two blocks, the next row had three blocks. And so we're saying how many blocks does it take to make a period if each pyramid has one more row than the last one. So in this example, we are going to make an explicit formula for that sequence. So in that example, we made a recursive formula. In this example, we're going to make a explicit formula for the same series. So basically, if we're looking at any term, our first row is going to be 1, and our second row is going to be 2, and our third row is going to be 3, right? We're making those periods, right? We're pyramids. We're stacking rows of blocks, and each row has more blocks. So eventually, we're just going to keep adding until we get to n, right? So we're just adding rows of blocks until we get to whatever this n happens to be. We don't know what it is yet. So I'm going to do a little trick here, and I'm going to write the same thing in reverse order. Okay, so this is just a little trick. So the same an, I could also write it as n plus n minus 1 plus n minus 2, right? I'm just writing the same thing, but in reverse order. N minus 3, I'm saying, okay, I need n, I need one less than that, and then I need one less than that, and then I need one less than that, right? And then that's going to go, eventually I'm going to get to 1. Okay, so what we're going to do is we're going to add these two rows together. So I'm going to get 2an, right? If I add these together, I get 2an equals n plus 1 2 plus n minus 1. So 2 minus 1 is 1. So that's just n plus 1. 3 plus n minus 2. 3 minus 2 is just 1. So that's n plus 1. 4 plus n minus 3. 4 minus 3 is just 1. So that's n plus 1. Oops. So hopefully we're seeing a trend. So that's just going to keep happening, right? We're just going to keep getting n plus 1, n plus 1, n plus 1 until finally here we just have n plus 1 again. Which makes sense that we would start with what we ended, because I just took this and I wrote it in reverse order in kind of a different way, but all I did was write it in reverse order. So these are very much equivalent. So this is going to happen n times. So, right, because I went from 1 to n in my first one. So I have n plus 1 n times. Hopefully we see why that is. I have n plus 1 plus n plus 1 plus n plus 1. I have n of these. So I can add them together, and that gives me 2an equals n plus 1s. I have n plus 1s. See that I have n of these. So I have n plus 1s. And then if I just want to solve for an, that's an equals n plus 1 over 2. So now, right, I could find, say, term 100. So when I had the way I had it before with the explicit form, with the recursive formula, to find N100, to find A100, I would have had to find A99, A98, A97. But now that I have an explicit formula, which, by the way, as you can see in this situation, sometimes the explicit formula is harder to find, but sometimes it's worth it because you need something like term 100. So now I can find term 100 where I couldn't, or it would have taken a really long time to find term 100 in the previous example where I had a recursive formula. So to find A100, I have 100 times 101, right? N plus 1 over 2, which, if you do the math on that, is going to be 5,050. 5,050. So this has been figuring out an explicit formula for pyramids. Again, sometimes explicit formula can be a little bit trickier than finding a recursive formula. So let me know if you have any questions, and I will see you in the next video.